here in wonderful western Nebraska. So that's why I wanted to draw a little bit more attention to it, kind of go through a little bit about what the Northern Lights are, how they work, and just a little bit behind the whole deal. Because I know my Facebook feed last night was a lot of just pictures from all over the Panhandle, whether it be Chadron. Chadron had some really great views, especially up on top of Sea Hill. So on the campus of Chadron State College, they were up on top of Sea Hill. There was a good view of it up there, especially because they got up above the lights. I know some people went out to Sioux County. Sioux County is not very populated, so there's not a lot of lights out there. So they got to see a lot of the different color of lights. For me, I just went out back of the school, was able to actually see it pretty well. About 8 o'clock last night, 8:15, you could actually see a lot of the red color in the sky with the naked eye. It's not very common that we can see it down here with just the naked eye. Especially the green and blue colors, they kind of blend in with the horizon very frequently. So in order to really see them and really draw them out, you have to capture them on your phone camera. You can, of course, take normal pictures with other cameras too, and they tend to catch them. You could have, honestly, a really low quality phone camera and still get really good pictures. I had some people that they've had their phones for, I don't know, 8-10 years, and they're really cracked up and everything, and they got some really good pictures still. So obviously, if you missed out last night, not a big deal, because tonight it's supposed to be very, very bright. More so focused on the northeastern portion of the sky. There is going to be some bluish green along the north, but a lot of your red is more so focused on the northeast. I don't know a reason why, but it tended to be more to the northeastern skyline that there was a lot more red than any other color. We'll get into why that is, but first, here's just a little brief preview of what the Northern Lights are. All right, so that's just a little bit of just basic, all the information that we're going to cover in this, just all in a matter of 2 minutes. November is actually going to be jam-packed with a lot of different space events. I know for my kids on Canvas, I actually provide a schedule of like when certain space events are happening. I know I'm pulling up Canvas right now so I can show you guys what's all going on. There's going to be a couple of meteor showers this month in particular that I want to briefly pause and talk about. So real quick, we're going to have the Leonid meteor shower coming up actually rather quickly between November 16th and 17th. I know that that's going to be a Sunday night going into a Monday morning, so it's going to be a school night. You're probably not going to be up super late, but if you get up early in the morning before the sun starts to rise, that's kind of going to be your peak hours. Is anywhere between midnight and about 4 to 5 a.m. Going to be your peak times for that. And then all throughout the month of November, we have a... Lisa Ledoux, please go to your English class. Lisa, go We have a Northern Torrid meteor shower. This one actually happens every single year throughout the month of November. So a couple of different meteor showers that we can get throughout the month of November. So those are our two main things. There's a big special moon event that actually happened earlier in the month. And then we're going to have a new moon actually closer to Thanksgiving. I think it's a few days just before Thanksgiving. So the moon's going through some cool things. We have a couple of meteor showers. We have the northern lights. We kind of have a mix of about everything for the month of November. All right, so what are the northern lights? The northern lights, of course, are a light display in our night sky. We saw that last night. We'll get to see that tonight. Very commonly seen closer to the poles, obviously. Explained a little bit about that in that short little intro video. It's kind of through a process of charged particles in the air on Earth and the particles coming to us from the sun. So all those UV particles, solar flares, solar wind brings it all the way here to Earth, where we get to see our sun particles dancing with our atmospheric particles here on Earth. We'll talk about some of these specific elements of what's in our atmosphere in a couple of slides. I think you guys will know it when I get to it, but got a couple of elements that do interact with the sun's particles when they come in. Okay, the first sighting of the northern lights actually happened in 567 BC. So 567 BC was our first time that somebody has recorded record of the northern lights. Was actually from a royal astronomer working for the king of Babylon. Actually recorded it on his stone tablet. No, not an iPad. They didn't have an iPad back in 567, but recorded it on his tablet, and that's our first actual recording of the northern lights. Of course, sometime later, 2,000 years later, we have plenty of artists that have done their own recreation and own record of the northern lights. There's one artist in particular that I'll get to here on the next slide. So two names for this phenomenon. We know the aurora borealis, and he mentioned the other one in the video. Two different names just based on where you are on planet Earth, whether you're in the northern hemisphere or if you're in the southern hemisphere. All right, so the artist I was going to tell you about is Frederick Edwin Church. So he actually has probably one of the most famous paintings of the aurora borealis, or the northern lights, displayed on screen right now for you. He was an 1800s artist, passed away actually in the early 1900s, but he did a lot of landscape painting, and he really focused a lot on the northern lights. He actually had found his website of all of his art. He had a lot of different paintings of the aurora borealis. He had some of our different mountain structures throughout the world. So really just loved painting the environment around him, and he just happened to capture the northern lights. And this is his representation of it. You can see the blending of all the colors. So a little bit of green, a little bit of blue, a little bit of red. Maybe even some yellow there in the middle. Tons of different colors. So a lot of artists, they've done their own kind of recreating of what they saw. So what is the exact cause of the northern lights? So what are some of the causes of northern lights? The main cause sits about 94 million miles away from us. So a long, long, long distance away. It might even be more than that. But a little ways away from us, obviously, that's where our sun sits. That's where we're going to get our solar flares and our solar wind, all of our UV particles from. That is responsible for triggering these lights and these interactions that we're able to see, all thanks to how they are reacting to one another. So a little bit of chemistry in the sky. We get to see chemistry at work. Right now, with this particular solar storm that we're experiencing, there is a specific scale that they kind of go through. I didn't provide the scale in here, and that's one thing I wish I did, but they kind of rate it similar to how we have like hurricane ratings and tornado ratings. They do it on a G scale, I'm going to have to look up the specific name for it, but they do it on a G scale. And so this particular solar storm is going to be one of our strongest ones. It's going to be classified, right now it's classified as a G3, which is a moderate solar storm, but it has potential, especially tonight, with some of the late solar flares coming in on the solar winds and getting through our magnetic shield into our magnetic field of Earth. We're going to maybe get that upgraded to a G4, which would be classified as a severe solar storm. So definitely some impacts with that. We'll get to the impacts on that here in a little bit. Right now, if you think about the solar storm and the eruptions, how fast do you think those solar flares and solar winds are traveling to Earth? Obviously, it's going to be in the millions of miles per hour. So how fast do you think the speed of those solar flares are getting to Earth? Anybody? A little less than that, actually. So, less than 100 million. All right, you're getting closer. You're getting warmer. So it's closer to 50 million. I will tell you it's not lower than 25. It's between 50 and 25. What was it? No. A little bit more. So you know it's between 35 and 50. It is 45 million miles per hour. That is the speed of all these solar flares and the solar winds coming to Earth. So 45 million miles per hour is what all those particles are hitting us at. Kind of a crazy thing to think about. Again, this all is just caused because of the sun and the Earth's magnetic field. So these particles come in contact with Earth's magnetic field, and at that point, we can see it at the poles interacting. And the reason why we see like the movement in the light is just because it's moving with our magnetic field of Earth. So that's why it appears that those lights are actually moving. I don't know here, last night when I looked at it, I couldn't really see the movement of the light. Did anybody see any movement with the light, or was it kind of just a steady light sitting on the horizon?
When I went out there,
okay. I was going to say, I think you see it a lot more with the green just because it's lower in the atmosphere versus the red. The red is a lot higher up in the atmosphere, so that could be another reason why maybe you didn't see the red move. There's a lot of variables, obviously, with it. All right, which brings me to another question for you guys. This one, maybe you know from chemistry, so maybe you can think back in your brain to chemistry. What particles or what elements are present in Earth's atmosphere that these solar particles can interact with? Obviously, one of them is what we breathe in every day. What do we breathe in? We breathe in oxygen. Okay, that takes up 20-something%. We'll get the exact percentage here in a minute. Takes up about 20% of our atmosphere. So what is the other 70%? I'll give you a big hint. I don't have a periodic table up in here, but it's on the right side. It is not carbon. It is nitrogen. Nitrogen is one of the other big elements in the atmosphere. So oxygen, and nitrogen are going to be our biggest contributors to our atmosphere. To kind of break down what our atmosphere looks like, we have 78% of it being nitrogen, 21% being oxygen, and our other gases take up that other percent. There's argon, there's carbon dioxide, there's carbon monoxide, there's a ton of other particular elements that are classified under that 1%. So there's a lot kind of shoved into that one little sliver of the pie versus nitrogen taking up majority of the pie. All right, this is kind of just a picture of what is actually going on as a visual representation. So we got some solar flares that are happening towards the surface of the sun. I wish I found a video of it. There were some really cool videos on the internet I saw earlier today of these solar flares. If you go on Google later today, Google some solar flares. There's some really good videos of this particular solar storm that's happening right now. There's a lot of good solar flare videos from some of our satellites. So solar winds carry it here. Some of them are bounced out from our magnetic shield. Some are absorbed. They get to come in and interact with our magnetic field. So there's not always going to be all of the solar particles making it down to Earth. Some of it is bounced out and reflected elsewhere into space. So we aren't the only ones that actually absorb it all. There's a couple of other planets in our solar system. I believe Saturn was one of them that actually has a similar phenomena to it. So Saturn, some of those planets that are actually further out actually have this capability as well. So super duper cool. All right, so here's a little bit about the colors. How do we get them? What do they mean? Looking up here, I know that a lot of us actually got to see probably majority of these colors that are up on the screen, which is very rare. Usually down here, I know with our last solar storm that happened, I don't know if that was last year or 2 years ago now. Last year. I know last year went out to Sioux County to watch it and was able to see just the green very faintly. I wasn't able to actually see any of the other colors. So this was the first time in my life that I was actually able to see a lot of the variations in color. Saw a little bit of the blue, saw some purple, saw red, green. We have all these colors happening at different levels of the atmosphere. So our green is going to be the lowest one. This is what you're going to see most commonly just above the horizon. So 60 miles up from 60 miles up and all the way up to 150 in the air is going to be your oxygen interacting with our sun particles. Same thing with the red. It is also oxygen, just at a higher level. So concentrations kind of do matter at the different levels of the atmosphere. So the higher up you go, you're going to have a lot less oxygen. So that is kind of why there's a little bit of a different color between the two sections. And then, of course, purple, blue, nitrogen. A lot of the purplish blue, I think in a lot of my pictures, were rather low. It says above 60 miles, so it's probably going to blend in with your green oxygen color that takes place, again, 60 to 150 miles up in the atmosphere. So when you think about the elements, oxygen is going to be your red and green, while nitrogen reacts with a bluish purple color. So that's where we get our colors for our aurora borealis. It is also the same for the phenomenon that happens in the southern hemisphere, obviously because the atmosphere is the same down there. All right, where and when is it most common to see them? Obviously for us it's a special treat to be able to see it as good as we are right now. Some of the countries where you can actually see the northern lights most commonly are going to be your northern and southern countries. I'm more so focused on the northern ones for this particular instance. Northern Canada gets to see them. Alaska is the only state in the United States that commonly sees them until we get some of these stronger solar storms. Norway, I have a good friend in Sweden. She actually says she gets to see them pretty frequently at night just because they don't have a lot of light pollution where she lives in Sweden. So it's kind of super cool to get some pictures from her to see the difference. Finland and Iceland, of course, are accompanied by that. Wintertime is the very optimal time. If you're going to go out, you're going to go stargazing, do anything that you're going to be looking up at the sky. I know it's super cold out. I know it gets chilly. Bundle up. But if you go out, October to March is the best time to see a lot of these space events happening. There's a lot of meteor showers and such that do take place during October and March. So those are going to be October through March is going to be your prime time to go out and look at the stars or look and see the northern lights, for example. So a lot of our times of being able to go up and look at the constellations, everything, it looks really great, especially in the wintertime. Not to knock on the summertime. Summertime also has some good meteor showers, but you can't see them as pronounced in the warmer areas you can in the cold. I need to do some research on why that is. Of course, it's important to kind of touch on the cultural ties and some of the stories of the past of what people believe, because some of our indigenous people, they had specific beliefs with things that occurred in the sky, whether it be our weather phenomenons, or even tying it back to what's happening out in space. So the Vikings, they thought that these lights were actually reflections from their warriors' armor. So they thought it related to battle, very similar to what the Japanese had. So the Japanese, every time that they saw the Northern Lights, they found it as a good omen, or something positive was happening in whatever battle they were fighting. A lot of the other ancient peoples, two of those bullet points right below the Vikings, it's either the spirits are at play, or they think that it's a specific message from the gods. Then you have some other indigenous people, the Cree, or indigenous North American. They're thinking that it's the spirits that have passed on, or loved ones that have passed on, that are just providing them guidance from above through the messages that they're sending through the colors or whatever else is going on in the atmosphere. Irish, they actually believe that the particles that are coming from the sky can be made into substances that could actually cure burns. So it's very interesting how everybody has, how each group has their own thoughts on this particular instance and some of the things that happen in our natural world. So what are some of our observational methods and studies? How do we get to actually observe this and get to know a little bit more about what the Northern Lights are doing? So we can use hands-on tools here on Earth, and we can use our tools out on space, and we get to use a lot of computer analysis. So the magnetometers, they measure the changes in the magnetic field when these particles start coming into Earth, when we start getting these strong solar storms. Then we have radar imagery, very similar to how we forecast our weather and our storms moving. They can also use radar imaging to see how these solar flares and solar winds are going to impact the Earth. Satellites, of course, we have a lot of satellites up there in space. They're measuring a lot of different elements, some of them being speed and density of our solar winds. Then, of course, computer modeling and analysis. This is used to predict the intensity of these solar storms, further forecasting, and they kind of take in this data and see, okay, how does this compare historically from the last couple of years, or even all the way back as far as they go with physical records of that data. So we can use physical tools, computer analysis, and satellites. So a lot of different ways that we can observe this. We have a couple of observatories that I'm sure had some special events going on with the solar storm coming through. So a lot of different ways that we can actually go through and look at it. So what are some of our impacts of these stronger solar storms? Our G3, G4, and I don't believe in the history we've ever had a G5 that has been recorded. So our satellite and radio communication, some of them have been impacted. I know some of the FM stations all throughout the country actually had some static on their broadcast last night. I know around here there is a little bit too. It's kind of interesting how that can impact that. GPS disruptions. Of course, this is going to be interacting with our magnetic field, so things can be thrown off when we have these big solar storms. And then, of course, one little piece of history, a cool fun fact. All the way back in the year of 1859, we had a big solar storm that did take place, and it actually took out our telegraph systems all around the world. Big solar storm. So it could do the same thing for us here. If we have a very strong one, just because we're so technologically advanced doesn't mean that we are immune to having damages done to our technology. So we could go without radio, or it could impact the power grid. There's a lot of different impacts that we could have depending on the severity of it. I know when it talked about the power grid, it talked about how the voltage could spike with some of the energy that's coming from the sun. So it was very interesting seeing the various impacts that we can have throughout these solar storms. All right. Of course, want to wrap up with just a couple of visuals. I know you guys have a lot of wonderful pictures to share too, so I'm willing to see those after we are done with this. But these are just a couple of the pictures I took last night. You can kind of see variation of the colors, especially in the one on the right. The one on the left, I tried to get just a picture of the sky almost directly up above me. Very, very bright red, about 8:30-ish last night when I was kind of calling it a night. Could kind of see some of the stars in that picture too. Super duper cool. On the right side, that's actually out on the highway west of town. I stopped at the historical marker out there where all the county sheriff like to park on occasion. There is a really great view right there. Got to get some good pictures facing north, so you can kind of see the blend of the green. Very, very vibrant green on the lower horizon. A little bit lighter blue as it mixed into the red and the magenta colors towards the upper part of the sky. And then, of course, right out back of the school, right by the football field, was able to grab some more pictures. More so focused on the northeastern sky in these pictures, so we're going to have the bright red, the magenta colors. Those are our main colors that you can see in the northeastern sky. Where you look more central north and more northwesterly, it's going to be a greenish blue. That's all I got for you.